Everyone, myself Deepak Shah from New Catholic Mission School, Jhabwa. Today's video is for class 12th mathematics chapter 7. Name of the chapter is definite integrals. So today's topic is some properties of definite integrals. So there are few properties of definite integrals which are very important for exercise 7.11 and also for the examination point of view. So the first property is if the limit a to b fx dx function is in the form fx dx a to b limit, then we change the limit by b to a if we write in the form minus b to a fx dx. This is the first property. Second property is a to b fx dx equals to, we split the limit in a to c fx dx and c to b fx dx. This type of properties are usually used in modulus type of questions. Third property, 0 to a fx dx equals to 0 to a f a minus x dx. Very important property. In many questions we use these properties. So 0 to a fx dx equals to 0 to a f a minus x dx. Then fourth property is 0 to 2a fx dx equals to 0 to a fx dx. Then minus a to a fx dx, there are two forms of this minus a to a fx dx. First is 0 to a fx dx if the function is even function. Even function means if we write this function in f minus x, then it becomes fx. So in this type of questions we use this property. And minus a to a fx dx equals to 0. Directly we write 0 if the function is odd. And how we find the function is odd? If function minus x equals to minus fx. So these are the 6-7 properties which are very important, and you can solve any question of 7.11 by these properties. So question number 1 of exercise 7.11. Second question, we start from second question because first question is very simple. So second question 7.11, integration 0 to pi by 2 root sin x upon root sin x plus root cos x dx. This is the question. So we take I equals to integral I equals to 0 to pi by 2 root sin x upon root sin x plus cos x dx. This is equation number 1. By using property 0 to a fx dx is equals to 0 to a f a minus x dx. So in this question we have 0 to pi by 2, it means value of a is pi by 2. So we write this function in the form 0 to pi by 2 root sin a minus x, it means pi by 2 minus x upon root sin pi by 2 minus x plus root cos pi by 2 minus x dx. We know that 0 to pi by 2 sin 90 minus theta is cos theta. So it is root cos theta or cos x. This is root cos x plus root sin x dx. This is equation number 2. Add equation number 1 and 2. Add first and second. We get 2i, I plus I, 2i. This 0 to pi by 2 is common, and root sin x upon root sin x plus cos x dx plus root cos x upon root cos x plus root sin x dx. So if we add these two, 0 to pi by 2, taking LCM, root sin x plus root cos x. So in numerator we have root sin x plus root cos x dx. These two functions cancel. So, we have 2I equals to 0 to pi by 2 dx, and the integration of dx is x and 2, and the limit is 0 to pi by 2. So, we write it as upper limit minus lower limit. So, the answer is pi by 4. So, this type of questions you have in exercise 7.11 by using the property. Okay. Next question, question number 4. Same question. In this fourth question, we have cos to the power 5x I equals to 0 to pi by 2, same limit, and the power of cos is 5, and sine to the power 5x plus cos to the power 5x dx. This is equation number 1. Same property, 0 to a fx dx equals to 0 to a fa minus x dx. So, it is 0 to pi by 2 cos 5 pi by 2 minus x upon sine to the power 5 pi by 2 minus x plus cos to the power 5 pi by 2 minus x dx. So, 0 to pi by 2 cos 90 minus theta is sin theta. So, it is sin 5x. This is cos to the power 5x plus sin to the power 5x dx, equation number 2. If we add both this, so we get, add first and second, 2I equals to 0 to pi by 2 sin to the power 5x plus cos to the power 5x upon sin to the power 5x plus cos to the power 5x dx. These two cancel. So, we get 2I equals to integration 0 to pi by 2 dx, and integration of dx is x 0 to pi by 2. So, I equals to pi by 2 into 1 by 2 means pi by 4 is the answer. Next, question number 5. Question number 5 of this exercise. Integration minus 5 to 5 mod x plus 2 dx. The question, the function is in modulus function, is a modulus function. So, first we put x plus 2 equals to 0. So, we get x, value of x as minus 2. So, we split this limit into minus 5 to minus 2 and minus 2 to 5 by using properties a to b fx dx equals to a to c fx dx plus c to b fx dx. So, the question will be minus 5 to minus 2 mod x plus 2 dx plus minus 2 to 5 mod x plus 2 dx. So, if we remove this modulus sign, then we get minus of this function plus, if we remove this modulus function, then we have plus sign. Why? Because in this function we have value of x in between minus 5 and minus 2. So, we get negative value. Now, minus integration x square by 2 plus 2x minus 5 to minus 2 plus integration x square by 2 plus 2x limit minus 2 to 5. So, first we put upper limit minus 2 square by 2 plus 2 into minus 2 upper limit minus lower limit minus 5 square by 2 plus 2 into minus 5 plus this limit 5 square by 2 plus 2 into 5 minus 2 square by 2 plus 2 into minus 2 So what we get? We get 4 by 2, it means 2 minus 4 minus 25 by 2 minus 10 plus this is 25 by 2 plus 10 minus 4 by 2 means 2 minus 4. Okay. So minus 2 minus 25 by 2 plus 10 and this is plus 25 by 2 plus 10 minus plus 2. So we get minus this 2 10 minus 2, it means 8 minus 25 by 2 plus this is 25 by 2 plus 12. So minus 8 plus 25 by 2 plus 25 by 2 plus 12. So 12 minus 8 4 plus 25 by 2 plus 25 by 2 is 25. So answer is 29 by 29 is the answer. Okay. So you can solve this question. Now next question. Question number 8. 0 to pi by 2, 0 to pi by 4 log 1 plus 10x dx. This is equals to I. So we used property, by property 0 to a fx dx equals to 0 to a f a minus x dx. So 0 to pi by 4 log 1 plus 10 pi by 4 minus x dx. So 0 to pi by 4 log 1 plus, we have the formula of 10x minus y, it is 10x minus 10y upon 1 plus 10x 10y dx. So I equals to 0 to pi by 4 log 1 plus 10 1 minus 10x upon 1 plus 10x dx. Now we take LCM. I equals to 0 to pi by 4 log 1 plus 10x LCM. So 1 plus 10x plus 1 minus 10x dx. This 2 cancel. So we get 0 to pi by 4 log 2 upon 1 plus 10x dx. Okay. Now by the property log m minus log n, we write log m upon n as log m minus log n. So 0 to pi by 4 log 2 dx minus 0 to pi by 4 log 1 plus 10x dx. This 0 to pi by 4 log 1 plus 10x dx is equals to I. So we put here log 2, this differentiation of dx is x, and 0 to pi by 4 minus I. Okay. So this I is in LHS and we get 2I equals to log 2 x 0 to pi by 4. Pi by 4 minus 0, 2 is in LCM, 2 is in right side. So log 2 pi by 4, this is the answer. of this question. Okay. Next question. Question number 10. 0 to pi by 2 log sin x minus log sin 2x dx. Limit is 0 to pi by 2 log sin x minus log sin 2x. We know that formula of sin 2x is 2 sin x cos x. So, we write this as 2 log sin x minus log 2 sin x cos x dx. So, 0 to pi by 2 log sin x minus log 2 minus log sin x minus log cos x dx. 0 to pi by 2. 2 log sin x minus 1 log sin x, it means log sin x minus log 2 minus log cos x dx. Now, we separate these three terms. So, log sin x dx 0 to pi by 2 minus log 2 integration 0 to pi by 2 dx minus 0 to pi by 2 log cos x dx. So, 0 to pi by 2 log sin x dx as it is minus log 2 integration of dx is x 0 to pi by 2 minus 0 to pi by 2, we write this by the property number 4 log cos 90 minus x dx. So, in next step 0 to pi by 2 log sin x dx minus log 2 pi by 2 minus 0 minus 0 to pi by 2 log sin x dx. These two cancel. So, we get minus log 2 pi by 2. This is the answer. Next, question number 12. X upon 1 plus sin x dx. Limit is 0 to pi I equals to 0 to pi x upon 1 plus sin x dx. So, we use property. This is equation number 1. Property is at the place of x a minus x 1 plus sin pi minus x dx. So, 0 to pi minus x upon 1 plus sin x, add first and second. So, we get 0 to pi x plus pi minus x upon 1 plus sin x dx. This x cancel by x. So, we get 2I equals to pi 0 to pi 1 upon sin x 1 upon 1 plus sin x dx. Rationalize the denominator. So, we get 0 to pi 1 minus sin x multiply and divide by opposite sign of these two terms. So, 1 minus sin x multiply and 1 minus sin x divide. So, 2 pi 2I 0 to pi 1 minus sin x upon, directly I write this term as cos square x, because 1 minus sin square x equals to cos square x. Separate these two. So, we get 0 to pi 1 upon cos square x dx minus 0 to pi sin x upon cos square x, cos x into 1 upon cos x dx. So, 2I equals to pi, this is 0 to pi sec square x dx minus this is 10x sec x dx. So, 2i equals to pi, integration of sec square x is 10x. So, limit 0 to pi minus 10x sec x is sec x and limit 0 to pi. So, after this you can put the limits, upper limit minus lower limit, 10 pi minus 10 0, both are 0, minus 10 pi sec pi minus sec 0, both are minus 1. So, you get the answer. Okay. Next, last question of this exercise, question number 17. Zero to a root x upon root x plus root a minus x dx. This is equals to I, equation number 1. By property 0 to a f x dx equals to 0 to a f a minus x dx. So, I equals to 0 to a root a minus x upon root a minus x plus root a minus x dx. So, 0 to a root a minus x upon root a minus x plus root x dx. Okay. Why? Because if we remove this bracket, then we get a minus a plus x. So, a cancel this, add first and second. So, we get 2i equals to 0 to a root x plus root a minus x, numerator of this 2 and denominator is same. So, root x plus root a minus x dx, both are cancelled. So, 2i equals to 0 to a dx, integration of dx is x and the limit is 0 to a. So, we put the limit a minus 0 and therefore, I equals to a upon 2. This is the answer. So, this is all about exercise 7.11 and you can solve the remaining questions easily by using these 7 properties. Okay. Thank you.